Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is partition list. So the challenge statement goes like this: given the head of a linked list and value x, partition it such that all the nodes less than x come before the nodes greater than or equal to x. So what you have to do is, for example, let's consider this sample input. Let's say this is the input list given to you, input linked list. Return this linked list. What we have done is the numbers greater than or equal to the given x is here 3. So we will club them together. This is greater than or equal to 3. This is greater than or equal to 3. This is greater than or equal to 3. We will club them together. And we will also maintain their relative ordering in the original input linked list. So the relative ordering should not be changed. What I mean by this is uh, here the relative ordering is not changed. 4 comes before 3 and 3 comes before 5. So it is correct, but you cannot take like this. Uh, 5, 3, 4. So here the relative ordering is not same, which was in the input linked list. I hope you are able to understand. So we will club them together while preserving the relative ordering. We will club the numbers greater than or equal to x while preserving their relative ordering in input linked list. So I hope till now you are able to understand what we are doing. Now we will check for the elements that are smaller than this x value and club them together. It is 1, 2, and 2. We will club them together while preserving their relative ordering. Club the numbers while preserving their relative ordering in the input linked list. We will do the same for these numbers which are lesser than x. 1, then 2, then another 2. So this is what we are looking for. Then what we will do is we will, let's call this list of smalls, linked list of smalls. This is linked list of bigs or equals linked list of big or equals. We will join these two lists. We will join the end of the linked list of smalls with the beginning of the linked list of big or equals. And what we will do is the head of the list of smalls after this joining operation. Return the head of linked list of smalls. First, we will be clubbing them together, the numbers lesser and the numbers equal or greater. This operation. This is operation number one. We will be performing this operation in a single go. Then what we will do is we will link those to linked list of smalls and linked list of big or equals by uh, attaching the last node of linked list of smalls to the first node of linked list of big or equals. This is operation number two. And at last we will return the head of linked list of smalls. This is operation number three. We will also check for the edge cases in case there is no linked list of smalls or there is no linked list of bigs. Then in that case we have to check. What we will do is we will take two linked list nodes. We will form two linked list nodes. One will be dummy head small. One will be dummy head big. Now what we will do is we will dummy head small point to this whole list. It will be pointing to 1, 2, 2, 2. Now this whole list can also be empty. In that case, dummy head small will be next will be pointing to null. There will be nothing here. So similarly, we will attach this dummy head big to the big list 435. We will change the value 4, 3, and 5. If let's say this list is list can also be empty. That case, dummy head big will be pointing to nothing. It will be pointing to null. Now, while doing the attaching operation, what we will do is we will make the dummy head. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the approach of the challenge. We will point dummy head small next to dummy head big next. So actually, if this will be the case, if The smaller linked list is empty. And if the smaller linked list is not empty, then we will attach this node. Let's call this current node. This current node to next of dummy head. This current node to we will attach here. This is case when the smaller linked list will be empty. Dummy head small will be pointing to next will be pointing to dummy head big next. And we will just return at last in all of the cases dummy head small dot next. If you are still not clear with the idea of the approach, it will be more clear to you in the coding part. So let's quickly dive into the coding part. What we have done is if the also let's have a quick look at the constraints. So the number of nodes in I did not check the constraints because we will be doing so in of n time. So n number of operations will be required. N here is nothing but the length of input linked list. The length of the input linked list is of maximum order of 200, and the input linked list can also be an empty linked list. So also the values of the nodes in the input linked list are in this range -100 to 100, and the value of x is in this range -200 to 200. So these are the constants. So in case your linked list is empty, you will return the empty node, a null node. In case your input linked list is not having any node. This is the dummy head small that will point to this will point to the head of small linked list. This current small node will point to will be the node pointer that will be used to form the small linked list. This current small node will be used to form the small linked list. Also, we will do similar things for the dummy head equal and equal or greater. We will declare the similar variables for the list of equal or greaters. Yes. So this is dummy head equal and greater. Or greater. This will be used to form the this will be used to form the equal or bigger linked list. What we will be doing, we will be forming both of the lists in one traversal of the input list. What you will do is you will take a pointer current which is currently pointing to the head of the input linked list, and you will be doing a single iteration over the input linked list. What you will do is you will store the next node of current and make the next node of current to null. This is being done so that after applying further operations, we do not form a loop in our final linked list. So you will be storing the next of the current and making the next of the current in is equal to null. And what you will do is, if the current node's value is smaller than or equal smaller than x, if the current node's value is smaller than x, then you will add it to smaller linked list. Else you will add it to linked list of bigs or equals. You will move the pointers used to make big and small linked list ahead, whichever the case it is. If it's smaller, then you will move the smaller pointer, current pointer ahead, and if it's the bigger or equal case, then you will move the equal or bigger pointer ahead. So at last you will be merging small and big lists. At last you will be joining the last node of linked list to the first node of big or linked list of bigs or equals. And you will return the first node of small linked list. So this is how you will be solving the problem or the challenge. So the code will be available in both of the languages, C++ and Java. If you are still having any doubts, please feel free to ask them in the comment section. Thank you for watching. Thanks.